Hello everyone, today I'm going to explain this Java code in which I'm going to find the position of a spacecraft in a Cartesian plane with the help of three satellites. I'm going to use triangulation to do this. The triangulation is uh, in general used like circumferences to find intersections. For example, a satellite sends a wave and then gets, oh, I have something in the distance here, the another satellite do the same, and then another satellite do the same. They are going to find the intersection in common. For example, this satellite have two intersections with this circumference and with this circumference, but there's only one intersection that is in all the circumferences. So we are going to use analytical geometry to do this. The first step is get the radio of this circumference, and this. The radio is, for example, the magnitude of this point to this point. So I'm going to use the formula of to get the magnitude of a vector. I apply this formula here with this function. I pass here in this object that is general equation uh, because we need to get the general equation of the circumference of every circumference, and to do that we are going to use the xy position of the satellite and the radio. The radio is the distance between every satellite and the spacecraft. I know that I say that we don't know the position of the spacecraft, but I put the position here only to get the radio because I am not sending the position in any part of my algorithm. Only here to get the radio. Because if I send a wrong distance, I don't going to get the position of of the spacecraft. So the idea is send a right position, a right distance. Sorry. Okay. To get or to operate the general equation, we need or I create a object that the name is general equation, and I create the x raised to y raised to x y and z positions because this is the general equation. So it's difficult to operate it with simple operations in code. I need to create this object. What I do is I send the x and y and radio because it's here, and I apply this formula, but I only do that. X raised to is equal to 1 because only there is one x raised to, and the x is, well, is the operation of a polynomial, right? X raised to 2 uh, multiplied by minus 3 multiplied by x, right? X is 1, so it's the same. And it's the same with this. So this is the operation, and with that, and C is only elevate this and this, um, and that's all. And then I plus all the C's. That is this and this, well, all that that, that are mathematics operations that you should know. Okay, but with this I get the general equation of the circumference. So here I got of every satellite. The second step is get the intersections between two circumferences. Well, in fact, I need the of three circumferences. So I'm going to use, for example, here the intersection between this and this, and the intersection between this and this. Why? Because with this, I'm going to find that they have two intersections. That is this and this. Then I get two positions, right? Two X and Y's. And then I get the intersection between this and this, or this and this. There's no problem, because I'm going to have again two X and Y's. And then I'm going to compare uh, which X and Y's are the same, and if they are the same, that's the position. Okay, and to do that, we need to do some operations. That operations are, first, I'm going to use the general equation of one satellite, for example, of this and this. And with that, um, then I'm going to subtract, for example, the first general equation to the another. And I'm going to get something like this. These two values, they are going to go, and I only going to have X, Y, and Z. And then I'm going to clear X or Y. And for do that, I use another class that is intersection, that is a extents of general equation. And I add new attributes. For example, a general equation Y and general equation X. Why? Because, like I say, I'm going to clear the X or the Y, and I need to save it here, because it's a little difficult to operate with polynomials here, so I have to create a lot of things. There's also this attribute that there is imaginary that I'm going to explain in the future, the coordinates, the intersection general equation, that is the final intersection general equation that I get. That is, for example, something like this. This is the final general equation of an intersection. Okay. First, to create the intersection, I need to send the one general equation and another general equation. I subtract all the attributes, and final, I get something like this. Here I'm going to do a condition. If y is different to 0, I'm going to do this. If not, I'm going to do this. Why? Because if y is 0, it's more easy to me, because I'm only going to use the x value. I'm going to use the quadratic formula to get the coordinates, because that's the next step. Use the quadratic formula, and with that, we are going to get the x and y. I use the quadratic formula here, and I only replace ed is equal to the ed that I have. But well, continue again. I create this. Well, I get first the intersection, that is this, and then I clear y or x, and I do that here. If y is different of 0, if I have 1y, I'm going to do this. So I'm going to get, well, it's the same, like, for example, instead of y, this is x, um, this is x, and the x have a y and a c. For that reason, I put this in, imagine that this is y and this is c, because I need to clear, right? So for example, if I have 3y, x plus x equals 0, then I need a so that's all. That's the clear of y, right? For that reason, I have here y x, that is this, x divided by y, that is this, and the c, that is this, yeah, and that. If I don't have y, I only need to replace the x, that is, for example, for x, if I only have x plus h equals 0, or I have 4, I only going to do this, and that's what is here. Okay, let's continue. And then with that, when I have the y or the x clear, I'm going to replace the x or y in one equation, in one general equation of a circumference. So we can use the first general equation, like I do here. That is the first general equation used to create the intersection, and I send here. I create a copy, a clone. It's a did copy, because this is appointed to another memory space. And I do the same again. If y is different of 0, I do here the replace of y or x. In this case, I only replace y. And for example, y raised 2, what I'm going to have? If we develop this binomial, you should know what I have. That is, I'm going to have here 1 x2. I'm going to add this to the x2 that is there. For example, if I replace this, the x, I'm going to get a 3 raised to y, that is, for example, 9 y. So if I plus 9 to this y, I'm going to have 10, right? It's only to explain that I'm going to do this. I apply all the x twice, the x raised 2 and the x and the c. And then the y raised 2 and y is equal to 0 because I'm going to get something like this, right? And then when I have replaced all the values, I'm going to use the quadratic formula. I'm only going to replace this, that is x raised to x c or abc with this in this formula, right? That is something that you also should know, and that's very easy to apply. And then when I apply this, I'm going to get if the square root is a major of equal to 0, it means that there is an imaginary number, right? So I can apply the formula. If no, it means that there is an imaginary number, and so I'm going to get true, and it means that it's sure that you send a wrong distance, because if you send the right distance between every satellite and the spacecraft, you don't have to, you aren't going to have imaginary. And that's, we do this, and I get the coordinates x1, x2, y1, and y2. Okay, when I have the intersection, it means that I am finalizing the algorithm, and then I only going to compare the coordinates. And how I do that? With this object. Sorry, this object. And I created with the help of the intersection objects, two intersection objects that are, for example, the intersection between Skywalker and Sato, and the intersection between Kenobi and Skywalker. Remember that this is a general equation that gets me the coordinates. And then I only compare, well, first I see if there is imaginary. If imaginary is false, it means that I'm going to do this. But if it is true, they're going to do nothing, and only is going to print that there is impossible to locate the spacecraft in correct distance. It is false. This is going to do this. There is compares the coordinates. For example, this intersection with this intersection, and if gets that the intersection in this circumference and with this is the same, it's going to see, it's going to put that locate is true. If don't find similar coordinates, it means the same. That, well, it's going to put locate false because it was impossible to locate the spacecraft, and I'm going to print the same in correct distance. That's all. So let's try this. and I have the position of the spacecraft. That is 3. And if I change the position, I'm going to get always the position. And that's all. I also create a mini test, but I'm going to continue doing that because it isn't finished yet. But for example, I test here that the creation of the general equation of the circumference is okay. That if you have any question, something, you can let me in the comments. Also, I'm going to leave the GitHub repository if you can check the code. That's all.